Hello, welcome to the presentation of Fatigue Detection System project as a part of my image processing project requirement at University of Florida. I am Harshavardhan Reddy, studying Masters in Computer Engineering at University of Florida. So, based on the recent researches and statistics collected on the factors leading to the accidents, fatigue is an important factor which leads to an accident, especially after continuous hours of driving without a break and in overnight driving, where eyes get tired easily because of the stress on the eyes during night times and because of the lighting conditions. These statistics show the need of designing a system which detects the drowsiness of the driver and gives a timely warning. The proposed fatigue detection system alerts the driver by detecting the fatigue condition by examining the eye state of the driver. The eye state is determined by real-time processing of the video of the driver with the help of a webcam in the car pointed towards the driver face without interrupting the driver or disturbing the driver. This is achieved by combination of Viola-Jones and skin color segmentation, which is used for faster and accurate detection of the face with the background of the rest of the car still being captured. After the face area is found, Viola-Jones algorithm is used to detect the eye state, and if the eyes are determined to be closed for 30 consecutive frames, the system raises a warning of falling asleep. In terms of time, if you have to say, if the eyes are found closed for 2 seconds continuously, then a warning is issued. The fatigue detection system includes multiple steps which are shown in the flowchart. Each stage in the flowchart will be discussed in the next few slides. Input to the fatigue detection system is given in the form of a video from the webcam in the car. The fatigue detection system takes each frame from the sequence of frames in the video and processes them one by one for fatigue detection. In this presentation, we take a photo as an input to show how the system processes each frame and detects the fatigue. One image with closed eye and one image with the open eye is taken as an input here. So the first and foremost step to be done in this system is the face detection. So these are the existing methods for the face detection, and we use skin color extraction to get the approximate position of the face, which helps in reducing the search area for Viola-Jones algorithm, which we are going to use in subsequent steps, and also reduces the execution time and increases accuracy. Skin color segmentation is done by comparing the RGB value for each pixel of the image with the threshold RGB value for the human skin. This helps in extracting the human skin from the given input frame. This makes the image binary with the skin having one value and the other areas of the input with another value. The extracted binary image is used to separate face from the image by filling in holes, which create separate solid blobs. A blob is a binary large object which is a collection of a binary data stored as a single entity. From the multiple blobs created, face blob has to be separated from the input frame by calculating the pixel density of each blob and thresholding it. The threshold is calculated by a trial and error method, and it varies based on the position of the camera and face in the image frame. Here we can see from the images shown here how the blobs are created and how the face is separated from the other parts of the image. After the face blob is created, the bounding box is used to draw a bounding box around the face, and this is provided as an input to the Viola-Jones algorithm. Viola-Jones algorithm has two stages. In the first stage, the algorithm is trained by providing the algorithm with the features unique to the object to be detected, and they are stored as classifiers. In this project, object to be detected are eyes. In the second stage, these classifiers are used to compare with the image provided, and the object to be detected has a high correlation value with the classifiers. Viola-Jones algorithm is developed by extracting facial features during face training where 6,060 features for eye, mouth and nose were identified from 4,916 images. Cascade Object Detector provided by MATLAB has inbuilt features to detect face and face parts with the classifiers from the Viola-Jones. The images here shows the output of the frame with the eyes detected and highlighted from the Cascade Object Detector. The first step in detecting the eye state is to convert the eye images into grayscale and then into binary. So in this slide you can see the eye images converted into grayscale, binarization of the image. So the gray image is converted into binary by giving a threshold value of eyes from the eye parts, and the threshold value is deducted from the various inputs taken. So after the image is converted into binary, histogram analysis is done for the binary image, which helps in determining the eye state. And for the fatigue detection, after the entire video is processed, if the eye state is determined as closed for 30 consecutive frames, then fatigue is detected and the driver is alerted. So these are the results, and here is the image of one of my friends, and we can see the eye state being detected here and also the histogram being plotted for each and every image. This is an example for the eye state, for the closed eye state and also the histogram. And this is the result obtained after the video is processed. You can see that the warning symbol arises when the user closes the eyes for more than 30 consecutive frames or 2 seconds. There are few limitations to this algorithm. So this algorithm may not work properly or will not work properly if the driver is wearing eyeglasses or sunglasses, because the eyes will be covered and it's difficult to extract the eyes from the image if the eyes are being covered by any other object. This algorithm could not work when tested during improper light conditions. For example, when there is a flash light beamed on face or very low light on face. So for overcoming this, we might need to point the camera in a direction which can extract the face with proper lighting conditions. And when the user face is rotated beyond 30 degrees or tilted beyond 45 degrees, this algorithm finds difficulty to detect the eyes. And if there is more than one person in the view of the camera, this system fails to detect the fatigue because it does not know how to handle it when there are four eyes in an image. Conclusion. So this proposed estimated method has demonstrated an accuracy of 90% in average for determining the eye pair. This can be improved by installing high quality webcams in the car and proper light focus on the driver without any disturbance to the driver. And for this algorithm has shown an accuracy of 95% for determining the eye state. This accuracy can still further be improved by using various driving indicators like blink frequency, fixed gaze, lane deviation, and amplitude of wheel turns, which help in determining the driving state of the driver, and it also improves the performance of the system. This resulting system is capable of detecting driver fatigue in real-time conditions. Thank you. Now I'm going to demonstrate the output in MATLAB. So here is the input image, and I created a GUI for this. So I'm providing the input image, and the face and eye detection part is going to detect the face from the entire image, and also it's going to highlight the eyes. And the eye state function determines the state of the eye, and the fatigue detection after providing the input. It processes the input and checks the eye state of the user, and if the eye state is found closed for more than 2 seconds, it gives a warning signal. Thank you.